Well, hey students, today we're going to be focusing on a couple of key concepts in introductory statistics that are useful when you're doing program evaluation in social work settings. And that is central tendency, things like mean, median, mode, standard deviation. We'll also do some graphic representations using histograms, and then wrap it all together. So let's get started. We're using the same human services data set that I used in some of the other examples. And you can see we have all of our data up here. And I've prepped a few things down here that we can use to keep this video quick. So in central tendency, we have mean, median, mode. Those are each different ways of kind of talking about where is the center, but it is different ways of accomplishing that. And so when you are looking at the mean, the way you use that in Excel is to use the formula average. So again, like I shared in the other video, when you're starting a formula, hit the equal sign first, and I'm going to type in average, and that comes up. I'll open up my parentheses, and then I'm going to select the cells here from age from C2 cell, and then I'll hold down my shift key to go down to the bottom here, select there, to B41. So it says C2 to C41, close my parentheses, and voila, we know that the mean age was 39 years old in this particular data set. But you might want to look at the median to see if it's a slightly different measure. Medians are particularly helpful when you have skews in your data. So for example, if you have a lot of young people and then just a few very old people, your median and mean are going to be different, but the median may be more helpful. Median is also really helpful when you're looking at things like income, because you often see a very long tail distribution, as we call in that situation. So let's take a look at median. You can find median by typing in equals median. This kind of makes sense. And again, we'll go C2. I'll just type it in this time to C41. And voila, we see that the median is 38.5. So if the median and the mean are pretty similar, that usually means that your data are not necessarily skewed so much one way or another. Now let's take a look at the mode. The mode is the number that most frequently shows up. I don't use the mode very much in program evaluation work, but sometimes it can be helpful. So I'll teach you how to do it anyways. And here you'll type in equals MODE, and then you can just type SNGL if you want to do just a single mode. C2 to C41. Sometimes there'll be more than one mode, and so you'll have to type in, there's a different formula for that one. You use the mode MULT, M-U-L-T, which I guess we could try and see if we have more than one here. M-U-L-T. No, we don't. So 29 was the most frequently cited age. And it just shows up with the first one that's there, so it looks like it's probably, what, 229-year-olds maybe? Yeah, 229. So not as useful of a statistic for our particular purposes. We can also then look at standard deviation. In this case, we'd be doing it for a sample. If we say that this was a group of people who participated in this program, but we're trying to think about people on a broader scale, you could use a sample standard deviation, but there's also one for population. We don't have to go too much into the details of that right now for stats, but I'll just show you how to do it. STDEV dot. Let's do the sample in this case. Oops. Div.p, and then I'll open up my parentheses here, and I'll do that same C2 to C41. And we see that we have a standard deviation of 12. Now, you may have seen in some of the your previous math classes that a standard deviation kind of tells you how spread out your data are. So if we have a mean of 39, the average is 39, that means that roughly 2/3 of the people are going to fit between 39 minus 12 and 39 plus 12 within about 24 age parameters. So 39 minus 12 in this case would be approximately 27 years old. And then 39 plus 12 would be 51. Hope I'm doing my math right there. So most people are between 27 and 51 years old in this data set. So that's what the standard deviation is useful for. So what's great here is too with the Excel formulas, and I wanted to show you this, we have our pre-score and post-score, which are also numerical pieces of data. And if I just take these 4 cells here and hit Control-C, copy them and paste them over here, voila, look, it does this mean, median, mode, and standard deviation for all of these cells and these cells respectively. So using formulas can be very helpful because when you're working across a set of data, it can kind of help you to calculate stuff real fast. So you see here, we have slightly different. Our pre-score was 4.6. Our post-score was 6.6. Hopefully that means it's showing growth in a positive direction between 4 and 6. Median and mode are 5 and 7 respectively. And standard deviation was about the same. So, we might conclude that we saw growth between the pre and post on average across all the folks in this particular data set. So that can be kind of useful. Now let's take a look at let's look at it kind of graphically. And to do that, we'll use something called a histogram. So I'm going to go ahead and highlight these data here. And let's go ahead and insert this chart. And we'll click on histogram. Ooh. Yeah, let's do that right there. Okay, and then you'll see here comes a histogram, and it's usually kind of bins of boxes, kind of where the data are all lying. But I find in histograms, it's useful to be able to modify them a little bit, because sometimes the way the bins show up here, between these cut points, maybe it's useful, maybe it's not. Between 1932, 32 and 45, 45 and 58, 58, 60, 51. Maybe those numbers are meaningful to you, but sometimes you want to do slightly different numbers. So I'll double click on the bins here. We'll click on the bins, sorry. And then come over to the data side here, and you'll see this is for updating your bins. Sorry, access options. I want to get to the bins options. Where bins, we can go, for example, bin width or number of bins. I'm going to change my number of bins here from 4 to maybe 6, 7, 8. You can see how you get more bins in there. It can be kind of seeing how the data are distributed more broadly here. Now you see that the data here are not distributed normally. So you don't see a normal curve here. So it's not like most people are between the ages of, 35 and 45, and then there's only outliers on the others. This is truly, representing all those different ages across that span. So the data are not normally distributed. But, getting a graphic of this can sometimes be a lot easier than looking at a long list of numbers, especially when that long list of numbers is like 200 or 300 people long and not like 40. So doing a histogram gives you a good sense of what does the spread look like in your data. So that's how you can put together a histogram. And over here, you can use your different adjustments here to change the number of bins, categories, etc., your bin width, all kinds of different things you can adjust here to make your graph looking lovely. Now, we've got our one example of a histogram here. The next thing I want to show you all is how to use formulas to calculate some percents, because we talked about percents and kind of breaking things down by subgroup as an important part of your work as doing program evaluation. So in this case, I'm going to show you how to do that with formulas. You probably, in the last example, saw some with graphs, but I think it's useful to be able to do it with formulas as well. So you'll see down here, I've got it set up with male, female, male, non-binary, and total. And we have an N and a percent. N is a count of how many of that particular group. So N here would be the number of people who identify as female, male, and so on and so forth. The percent is the percentage, what percentage of the whole group are identifying as female. So I'll show you how to do both of those. So for female, what y'all enter in here is equals, and I'm going to use a great little formula called count if, and open up my parentheses. And the idea is you're going to count how many in a particular range meet a certain criteria. So count if, I'll then go to gender, I'll hold this down, and I'll hold my shift key, go down to 41, and voila. So count if D2 to D41, and I'll hit comma, and then in parentheses down here, I'm going to put, actually, I don't even think I need parentheses. I'll just type female. No, I do need parentheses inside the parentheses. Okay. Count if female, voila. So you'll see here in my formula up at the top, it says count if D2 to D41 female. So it's counting all those who identify as female in that particular set. I can take that same formula and copy it and move it down here. And this time what I'm going to do is I got to change it though. So it changed my numbers. So I'm going to put that back to D2 and D41. And then here I'm going to write male instead of female. And voila, we see it's 16. And I can do the same thing for non-binary as well. Going to D2 and 1. We'll say non-binary. Oh, I didn't quite type that right. So you gotta type it exactly right or it doesn't work. So if I put in there just like so, voila, we see we've got up to 3. Now I can also get a total, and you can use a total by just summing all of the cells that have information in them. And to do that, you can use the count A function. So I'll do that, count A from D2 to D41 again. And voila, we see that's 40, which is exactly right. So now you see 21 female, 16 male, 3 non-binary, the total of 40. Because I have my total here, I can now calculate percents as well. And I'm going to do that using Excel rather than trying to go back in there and guess it or do the math work on the side. So I'll hit equals, here, and I'll say this cell, which is L44 in this case, and divide that by the total of L47. But I'll show you a neat trick here too. If you don't want, when you drag, so when you notice I dragged them down for male, female, and non-binary, it changed where the cells were coming from. But if I change this and put a little $ in front of 47, it's going to lock in that it's going to always be 47 even when I click and drag. So I do that right there, and watch I click and drag, and you'll see, voila, it calculates these correctly and changing from L24, 45, 46, but it changed 47 stays constant all the way through there. So now I have my percents. So they're expressed here as decimals though. So I'm going to want to highlight those and go up here and click on percents, and voila, I've got my percents 53, 40, and 8% respectively to be able to have my frequencies and percent. So N here, we use the term frequency for that one. And then this one, we use percent for this. Anyway, I hope this is a useful tutorial to help you describe your data. More coming soon. Have a wonderful week.